Hello everyone, am I visible? Hello everyone. Yes, okay, good. Okay, let me start then. Let me begin. Okay. So first of all, there is some good news that let me share and tell you. So Unacademy Champions League is back once again for you. So you have got these test dates, questions and time. That group stays so 14 and 21st November and then 20th November. You can note the change of time, right? This is a 1 to 2 p.m. Earlier it was some other time. Now it is like 1 to 2 p.m. and 1 to 4 p.m. So 25 questions and 75 questions. Lot of prizes. It's almost raining prizes. So do try to grab those prizes and of course gain knowledge also. Next is this duration. This price reduced by 10%, so you can subscribe or you can tell your friends also to subscribe. That's all for right now. Major thing is this, that practice until you are perfect with Unacademy T20 Championship Test Series, 20 questions in 30 minutes. So all those things you can do. Okay. So let me go to the document and show you. So let's start my class. Okay, so before I start this, let me add some pace and let me tell you what I want to do about it. So first of all, this is a very simple inequality, or say simple identity, but it has got lots of applications. So let me write first what we mean by this, and let me derive it 2-3 different ways. So you have got a cubed. The identity that we are studying now is this. That is a cubed plus b cubed plus c cubed minus 3abc. So it factorizes, right? It factorizes as a plus b plus c times a squared plus b squared plus c squared minus ab minus bc minus ca. I'll try to prove it in 3 different ways so that it will be very like rewarding for you to see that different things can be done. So first method is this. The first method is simple, that I'll make the sum of 2 cubes in 2 different ways. Means I will use x cubed plus y cubed is x plus y whole cubed minus 3xy times x plus y, and another same thing but rearranged differently. And so other thing is that I will of course use that x cubed plus y cubed is x plus y and times x squared minus xy plus y squared. Both of them will be used in this particular problem. So let's see the proof. It's an elementary proof, but there are 3 different things, so you may enjoy that. So a cubed plus b cubed plus c cubed minus 3abc I'll write as, first I club these together, sum of 2 cubes, right? So sum of 2 cubes, so I will write here a plus b whole cubed minus 3ab times a plus b and plus c cubed minus 3abc. If I combine the second and the fourth term and club together first and third, I'll get a plus b cubed plus c cubed minus 3ab nicely comes out common, and you've got a plus b plus c. That's good. We wanted this expression a plus b plus c, so that have come here. Now on these two I play again sum of 2 cubes, but in the second form. So this is a plus b plus c and then a plus b whole squared minus c times a plus b and c squared and minus 3ab a plus b plus c. Now a plus b plus c is common throughout, so I can take this common. I can simplify this a bit, so I will get I'll get a squared plus 2ab plus b squared. Does not look symmetric right now, but remember there is another term also, and so you've got negative of 3ab. Now things are in good shape because we ultimately got a plus b plus c times a squared plus b squared plus c squared, negative of ab, negative of bc, negative of ca. So this is the expression that we hoped to factorize. So this is nice one. So this is very elementary proof, sum of two cubes, because some of the students must be of class 8th or 9th, so they will understand this better if they view the video later also. So this kind of thing is there, that you got this. Okay, let's go to this one. Let's do something else and try that. Okay, now next I will do two more proofs. So other proof idea will be like this. Let me add some page. So other proof idea will be this, that what I can do is a cubed plus b cubed plus c cubed minus 3abc. So I can write like this, that you have got a cubed plus b cubed, a cubed, a cubed plus b cubed plus c cubed minus 3 times abc. Now other way is this is a very different proof actually, that polynomials. So say that t cubed, we understand that t cubed minus a plus b plus c t squared plus ab plus bc plus ca times t minus abc equal to 0. Minus abc equal to 0. This has the roots, this has the roots, this has roots, this has roots a, b, c, right? This is all right, that this has roots a, b and c. So if this has roots a, b and c, I can plug it a here. So I'll get a cubed minus a plus b plus c times a squared plus ab plus bc plus ca times a, and minus abc equals 0. Similarly, we can have b cubed also, right? So b cubed minus, I will write now sigma a b squared plus sigma ab times b minus abc is 0, and again c cubed. It's an elegant proof, c cubed, elegant proof using polynomials. C cubed minus sigma a c squared plus sigma ab times c minus abc equals 0. You can add all of them. When you add all of them, you get a cubed, you get a cubed plus b cubed plus c cubed minus sigma is common. You have got a squared plus b squared plus c squared, plus you have got ab plus bc plus ca, and times a plus b plus c, and minus 3abc equals 0. And so straight away you get a cubed plus b cubed plus c cubed. Transpose everything on the right side. You get a plus b plus c, and then a squared, b squared, c squared minus ab minus bc minus ca. So you got this kind of thing, right? So this is what you will get: a cubed, b cubed, c cubed. A cube, b cubed, c cube is this one, minus 3abc. So let me just rewrite. So this is a cubed plus b cubed plus c cubed minus 3abc equals this much. So this is this one. Okay, someone is telling that your forward link is not working. Forwarded link. It must be working. Just check. There was a new link because there was some technical glitch. So Chiranjit, you can check that. Okay, so this is this one, that a q, b q, c q. Now third proof uses determinant. Third proof uses the idea of determinant. So third proof is like this, that so this is proof 1, proof 2, and proof 3rd. So again we do the proof, that one. That proof is like this, that we understand that a cubed plus b cubed plus c cubed minus 3abc and negative of that, this is abc, this determinant bca cab. This we can get by expanding. this we can get by expanding. Simply expanding, you will get this one, or using Sarah's rule, we will get this directly. Another way I can do it by some manipulation. So another way is that I will write this determinant D is ABC. This determinant is ABC, BCA, and CAB. And you can add the column. So C1, add to C1 all the columns, C1, C2, C3. And so this transforms as A plus B plus C, A plus B plus C, A plus B plus C. And this is BCA and CAB. A plus B plus C I can take common at the first bracket. And then I can write 1, 1, 1, BCA and CAB. This is what I can write. So this is A plus B plus C, and now maybe little lag is there, maybe just check, although sometime there is some lag, but it will not be much. Okay, so A plus B plus C, and then I can again transform R2 minus R1, but then directly doing also is fine because we do not know anything about it. So BC minus A squared, it will be, if you here see BC minus A squared, so sigma, so ultimately you will get AB plus BC plus CA minus A squared minus B squared minus C squared. That's negative of what we want, and then it is actually this. So both are equal. So this way we will get that this is negative of A cubed plus B cubed plus C cubed minus 3ABC. So this is the derivation. So I derived using 3 ways. First derivation, let me tell you, first derivation was using the sum of 2 cubes written in 2 different ways. That was one. The second derivation was based on recognizing that ABC are the roots of some polynomial, namely t cubed minus sigma a t square plus sigma ab t minus abc equal to 0. And because these are roots a, b, and c, t can take a, b, and c in turn. I can add them up, and I will again get the same expression. And third was a creative thing. Third was determinant. That we know that the value of this determinant is this one by Sarah's rule, and we evaluate one determinant 2 different ways. One way was Sarah's rule, other way was we do some transformation, and then we are getting correct. So that way we'll get. So these 3 are the proofs of it. I hope that some of 2 proofs must be new to you, right? Especially determinant proof, because it is something very fundamental to maths, that writing something in 2 different ways and then proving it. So that's what we did. Okay, there is also another thing that is interesting here, of complex numbers, because sometimes we do that also, and then some more things we can do. So let me tell you something more about this. Let me rewrite again. So a cubed plus b cubed plus c cubed. Many contest problem, many Olympiad problem have asked this. Even JEE advanced questions were based on this. So this is really something important, and students do forget that. So a cubed b cubed is 3abc. I can write another way, a plus b plus c and half, and I can write as this as a minus b squared plus b minus c squared plus c minus a squared. Like that you can write, because ultimately we are getting, if you remembered, a squared b squared c squared, a squared b squared c squared, a squared plus b squared plus c squared, negative and negative bc, negative ca. This I will get as half times 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ca, which I can write as half times a minus b whole squared plus b minus c whole squared plus c minus a whole squared, this way. So this is the same thing. This is the same thing, right? Okay, now this is something like this, that one can say one more thing, some deductions one can do. See, of the 2, let me write the other form also here. That a cubed plus b cubed plus c cubed minus 3abc is a plus b plus c times a squared b squared c squared minus ab minus bc minus ca. This is one and this is second. See, sometimes second form is useful, sometimes first form is useful. Okay, I will do many examples. We will find that they really make great use of second form sometimes, and sometimes first form. Second form is people don't use often, so this is the one of the neglected forms. So please do remember that this form also is there. It might make your simplifications easier in many problems. Okay, some deductions, some small deductions, that if a plus b plus c is non-negative, then anyway this is non-negative, right? The non-negative, then a cube plus b cube plus c cubed minus 3abc greater than or equal to 0. As sum of three squares is always non-negative, and abc are of course real. So it means as sum of squares, the second factor is always non-negative. So we'll get this kind of thing, deductions. If ABC all are positive, then of course things are positive, and that can constitute a proof of AMGM. If you want to prove AMGM inequality for three variable, AMGM inequality for three variables, it's a tough proof for people. They don't remember. So like this, three variables, so means I want to prove that p plus q plus r divided by 3 exceeds or equals cube root of pqr. That is AMGM for three variables. Take pqr to be positive. If they are non-negative, nothing is to be proved, right? So pqr. Now this is coming directly from here, right? If abc are positive, we know that if abc are positive, if abc all are positive, then of course a plus b plus c is positive, and so a cubed plus b cubed plus c cubed is equal to 3abc, this one. And because p is there, so what I can do, that I can write a cube as p, there will be some cube, right? A is cube root of p, or I can write a is cube root of p. So I can write here p plus q plus r is equal to 3 times cube root of pqr. Cube root is always defined for a number, right? Cube root is always defined. So we will get like this. So we get 3 times cube root of 3pqr. And so AMGM inequality is proved. That's a good proof. Because you see, you can prove for 2. Then for 4 you can use Cauchy's method. 4 powers of 8. 2 means 2, 4, 8. You can branch in sum of 2 or 4. But then for this you can't do always. So that is one important application of this, that proving AMGM inequality for three variables. So these are some of the things like that. Now I will do some problems, so that I tell you that many contest problems will often ask this in different forms. So let me start with 1-2 problems and tell you its power. So our very first problem is an Olympiad problem, but it is a small one, like it was just asked in class 8. Okay, so this is just to realize that okay, you can have those things. So it is like this, that first of all you have got this one, that a cube, a minus b cubed plus minus c cubed. So what I do here, that I do write this. So this solution will be your a cubed. This solution is a cubed. Let's check. So this solution is a cubed plus b cubed plus c cubed minus 3abc. If I write, then I can write this as a plus b plus c. I can write this as a plus b plus c, and instead of writing a squared b squared c squared minus ab minus bc minus ca, I would like to write it as half a plus b plus c and a minus b squared b minus c squared plus c minus a squared. And this value is given to be 6. This value is given to be 6. So I'll get So I'll get, okay, but then come back, good to see you again, half times a plus b plus c times 6. So that is 3 times a plus b plus c. So now I will get a cubed plus b cubed plus c cubed. I transpose to this side, so 3 times a plus b plus c plus abc. So we got this proved. So some couple of examples, first examples are just to make you an expert in just understanding that how things look. They are not especially difficult. More difficult or more competitive will come later on, right? This is just to make you acquainted with the equality, that okay, this is how we do. Okay. Okay. Okay, this is this a cube b cube c. Again a plus e plus c is 1. So again I can write, again my solution will look like that. I can write, starting point is a cubed. Starting point for me is again a cubed plus b cubed plus c cubed minus 3abc, and that equals again a plus b plus c and a squared b squared c squared minus ab minus bc minus ca. But I can write this as a plus b plus c, and because a plus b plus c is given to be 1, I write this in terms of that one. So I write a plus b plus c whole squared minus 2abc, so minus 3ab minus 3bc minus 3ca. So that is a plus b plus c, and this is 1. So you will get 1 minus, so I think all 1 only. So I can write 1 times, so that is 1 minus 3 times ab plus bc plus ca. I can take this one on the left hand side, so I get a cubed plus b cubed plus c cubed minus 1. That is 3 times abc minus ab minus bc minus ca. So we got this one. So this thing is done. So these two are basic examples. Let's move to next one. Next one looks like, see, this is sum of 3 cubes, right? Sum of 3 cubes. So what comes to your mind? If this is sum of 3 cubes, what comes to our mind if we see it first? That what sum of 3 cubes have to do with this kind of thing? Sum of 3 cubes. So can I say that if sum of 3 cubes is there, then let's explore that what this number means. So I will write, first of all, I'll change notation. I'll write x equal to negative a by 2 to see that what kind of thing it holds. Negative a by 2 plus b by 3 plus c by 6. Y I will take as a over 6, negative b by 2 plus c over 3. See, x corresponds to a, b to say c, b to a, y to b. So this is this c by 3, and g I will take as a over 3 plus b over 6 minus c over 2. This we can take, right? If this we take, then I can add x plus y plus g. It discovered that x plus y plus g is something good, something interesting. So x plus y plus g, let's take coefficient of a only, right? So we'll get 1 by 3 plus 1 by 6. So a times 1 by 3 plus 1 by 6 minus 1 by 2. So that gives you 0, because this is just 0. So we got x plus y plus g 0. So sum of cubes, now question becomes that sum of cubes given to be 1 over 8. You know that sum is 0. So I know that sum of cubes is 3 times the product, right? And then let's write x in different way also. That if I take 6 as LCM, I get here negative of 3a plus 2b plus c. This I get x. If I take here LCM x, I get here I get a minus 3b plus 2c, and if I take here it is 6, I get 2a plus b minus 3c. So you see that these numbers are coming up. A minus 3b plus 2c, this is this, 2a plus b minus 3c, and minus 3 plus 2 plus 8. All numbers are here, and these are my x, y, and g, right? And this is 1 by 8, and their sum is 0. So we conclude that So we conclude that x plus y plus g, x cube plus y cube plus g cube is 3 times xyg. So 3 times, and xyg. So xyg is of course this one. No, 3 times xyg of course is this one, and 1 by 8 I will write, and x is here. So 3xyg. So 1 over 8 is 3xyg. So 1 over 8 is 3 times an xyg. So you have got this one, all product, and then upon 6 cubed. So we can write a minus 3b plus 2c. We can write 3 times a minus 3b plus 2c. Then 2a plus b minus 3c. You just have to copy it, just all. 2a plus b minus 3c. And then you have minus 3a plus 2b plus c. Minus 3a plus 2b plus c. Right? And this all divided by 6 cubed. 6 cubed. So you have got a minus 3b plus 2c. And all this product equals 6 cubed by 8 times 3. This one, 6 cubed by 8 times 3. 6 cubed by 8 times 3. So I can write 666 over 8 times 3. So that is 326. And then you understand that now you will get the answer, right? Because 3xyz is there. So I mean that you are getting, this is 326. So you are getting 72 over 8, and so you are getting 9. And indeed, this was the question to be proved, that you prove that this equals 9. So it looks, this problem is looking some kind of different problem that maybe for brute force or something, but ultimately by doing all the things we are able to reduce it to some other form. So is that clear? Is that good enough? That you got this idea that you can do this one? So real numbers is there, then we are getting this kind of thing, 9, 1. So this can be asked somewhere that, okay, this is this, then find the value of, find the value. Then you must think that, okay, maybe the idea is that x plus y plus g is 0. No, xyg looks like that because sum of cubes given and some product you are asking. And obviously they have taken LCM here, here no LCM. That is also one thing. Okay. This is again an easy problem. So first couple of problems are easy, so that the younger children, maybe class 8th or 7th, maybe these people will have much background, and as we go along we will have more challenging problems and contest problems also. So first of all, here you have got this kind of thing, that x minus a. So x minus a, b minus c. So what I will write, that I will just name. So I'll write, say p is x minus a times b minus c. So I can write x times b minus c minus a times b minus c. Q is x minus b times c minus a. So x times c minus a minus b times c minus a. This one. So if I write p plus q plus r, that is sigma p, you know, notice you will get sigma x times b minus c minus sigma a times b minus c. They are both cyclic sum. X comes out, so x times sigma b minus c minus this one. So this is 0. This is 0, and this also is 0, because a sigma a b minus c is a b minus c b c minus a plus c minus b, and you will find that these all are 0. So sigma, this is 0, and sigma b minus c is 0, but sigma a square b minus, this is not 0, and sigma a cube. In fact, they have got good factorization, which I will take up in one of the lessons. So sigma a square b minus c is not 0. Suffice to say, not 0. What it is, that also is beautiful thing. Okay, so this is one thing we will get. So sigma a squared b minus c is not 0, as long as a is not b or a is not c. Okay, so we got this kind of thing. X is here, x into 0, and this is sigma, this is also 0, 0, and so 0 is the answer, right? That this one, p plus q plus r. Okay, so p plus q plus r is 0, and so but we want p cube plus q cubed r cube, so p cubed plus q cubed plus r cube, sum of 3 cubes is 3 times their product p q r, and so my answer is 3 times p q r. So I can write 3 times x minus a, x minus b, x minus c, a minus b, b minus c, c minus a. So like that we'll quickly get. So this we have. Yes, Akshat, this class is very much relevant for JE, because a cubed plus b cubed plus c minus 3abc is indeed covered in JE. They have given many questions based on that. Also, this is a standard for lesson that we must know. Okay, let's go to next one. Find all real numbers ABC such that it is 0. So again, sum of 3 numbers. So we have got p plus q plus r 0. This will implies p cubed plus q cubed plus r cubed is 3pqr. 3pqr. Now we are applying on this one, root 3 cube root a minus b. So what I will get? I will get here this. I will get here, this is p cubed, so a minus b plus b minus c plus c minus a is 3 times cube root of a minus b, b minus c, c minus a. So this is 0, you see this is 0, and so 0 is, you can cube it, a minus c, b minus c, c minus a. A minus b, b minus c, c minus a. So you see it is 0 when 2 of them are 0, right? At least 2 of them 0. If this is 0, at least 2 of them should be 0. At least 2 of a, b, c are 0. Or are not 0, equal, I can say equal. 2 are equal. Even 3 also will come, but at least 2 are equal. That way it will be done. So this is how we will do this kind of thing. That 3 times cube root of this one. So these are the examples which we are doing. Find all real numbers given because cube root is defined and all things. Next is this identity, which you can try to prove for a moment, because what is happening here is that it is an extension of this one. See, we know that if a plus b plus c 0, then you know a cube plus b cube plus c cube equal to 3abc, right? Sum of cubes is product of 3 times their product. If sum of numbers is 0, then a cubed plus b cubed plus c cubed equals 3 times their product. This is what is known, right? This is known. It is just an improvement on this. Now there are 4 numbers. And you were saying that sum of cubes of these 4 numbers, so this sum of cubes of these 3 numbers, sum of these 4 numbers is 3 times their product taken 1 at a time. No, 3 at a time. 1 at a time, no, 3 at a time. ABC, ABD, BCD, and CDA. This looks okay. Looks good. Looks good actually. So I can prove it like this. First I'll use this one, a cube plus b cube plus c cubed minus 3abc, right? A starting point is this. So a cubed plus b cubed plus c cubed, I will write a cubed plus b cubed plus c cubed minus 3abc I'll write as. So I will write first of all a plus b plus c, that is 0, a plus b plus c. Okay, a plus b plus c, and times a square b square c square minus ab minus bc minus ca, which I can write as, because a plus b plus c is something good, I get a plus b plus c, a plus b plus c whole square minus 3ab minus 3bc minus 3ca. This is what we get, right? Why I am doing it? Because given a plus b plus c is d minus d, right? So I can put it here. So I'll get a cube plus b cube plus c cube. Next line is your answer. Minus 3abc equals a plus b plus c is negative of d. So negative of d cubed because negative, and then minus 3 times a plus b plus c and ab plus bc plus c, which is again minus d. So minus d cube plus 3d a plus b plus c ab plus bc plus ca. Right, sorry, a plus this is a plus b is gone. Now this is this d cube. So now we are done, because we get a, this is 3d. I should write rather 3d. So this is 3d, this is plus 3d, right, plus 3. So we get a cube plus b cube plus c cube plus d cube equal to 3 times, and this you have got abc plus abd plus bcd plus cda. Got my point? So sum of numbers taken 3 at a time. So we got this one. Sum of 4 cubes. Sum of see, if a plus b plus c was 0, if a plus b is a good improvement on it. If a plus b plus c was 0, which I'll always use, if a plus b plus c was 0, so sum of cubes is 3 times the product. Sum of cubes is 3 times the product. Similarly, here also we are doing that if sum of 4 numbers is 0, then sum of their cubes equal 3 times their product taken one at a time. So this number is relevant. So this we got. This also was a good problem, inspired by the same identity. This was one Olympiad problem. I think it came in PRMO, Punjab PRMO. It came in PRMO Punjab. Earlier, different region used to have their own exam. After some time, PRMO was standard, but before, if the state felt that it has got more students, then they can conduct a PRMO. They were at liberty, right? So it was based on that one: AQ, BQ, CQ. Let's do it. So here, this first thing, 1 by A, 1 by B, 1 by C equal to 1. This can be written as AB plus BC plus CA equal to ABC. I can write like this. That is correct. That is first one. Now I want this one. AQ plus BQ plus CQ minus 3ABC. No, 3A square, B square, C square. So A square, B square, C square also is there. And we have to prove this one. So I can factorize a cube plus b cube plus c cubed minus 3abc this factorizes as 3 times. One factor is a plus b plus c times a square, b square, c square minus ab minus bc minus ca. That's all right. And it is given to be 3 times a square plus b square plus c square, right? It is given to be this 3 times. So what I can write is this, that here I can write this as that this, if I take common here, or I use this hypothesis, I can write this as 3 times a square, b square, c square, and then 3 times a square, b square, c square, and then minus abc, correct? So I can write this as minus of, and abc is this much, so I can write minus ab minus bc minus c, just replacing abc, and this is a plus b plus c times a square, b square, c square minus ab minus bc minus c. Now these are not equal to 0, right? Because abc is non-zero real number, not all equal. So this is not 0, not because a squared, b squared, c squared minus ab minus bc minus ca is half times a minus b square, b minus c square, c minus a square. This one. So we do like this. So it is always positive, or at least not 0, because abc are non-zero real number and not all equal. So it means we can cancel them, and we will end up with a plus b plus c equal to 3. It was an easy question, but then the tough part was maybe this cancelling. If you do not do this, then you stand to lose some credit on the question. So this was okay, good one. So is that clear? So right now still we are doing some applications of the identity a cubed plus b cubed plus 3abc. Some identity applications. Okay, let's go to next one. Let's go to next one. This is a number theory problem. This is a number theory problem for Olympiad. So I would like you to try it for a moment before I tell you a solution. Let me quickly grab a glass of water or some water. Let me take. So this is a number theory problem. And then you may do better than this. So in any idea, somebody can give the idea in the chat box that how you will do it, how you plan to do it, this number theory problem. Admittedly, it's a good problem. Okay, let me begin by saying this, that these numbers are given to be rational number first of all, right? No, nothing is like integer, right? So what I do is that first of all I use this one, that p plus q plus r equals 0. This implies p cubed plus q cubed plus r cubed is 3 times p q r. This first I do. Of course, converse is not true. I don't need also. So I'll get a cubed. So solution begins on this note first of all. So first of all it begins that a cubed plus b cubed, so 2b cubed plus 4c cubed equals 3 times a times b times c and cube root of 2 times 4. So actually I get 6 abc, this one. So I get a cubed. So I get a cubed plus 2b cubed plus 4c cubed minus 6 abc is 0. Now assume abc are all integers. Even if they are not, they are given to be rational. Even if they are not, what we can do, you can multiply by the least common multiple of denominators. You will multiply by the least common multiple of denominators. What would denominators come? So you can multiply by the least common multiple denominators and get integer numbers. So assume abc are integers. Without loss of generality. So without loss of generality, we can assume abc to be integers. Okay, they are integers now. Now, if they're integers, then first thing you note, so I can write even a1, b1, c1 or a1, you can check it. Okay, so first thing you note that 2 divides a must be even. One can, and they're integer. We can assume this also even as we can assume that abc are all odd. Nothing is, first of all, nothing is even, right? So because if something is even, then 2 will come out of it, right? If something is even. So I can assume that abc are all odd, right? abc are all or at least, okay. So if I do this, then I will prove that at least one must be some kind of thing, right? So for that you do this one, that a is of course anyway even, that you get now. And then if a is, I think I may not need that assumption. So if a is odd, let me check that whether I need the assumption or not. Okay, so anyway I can prove about a that. So first assume that abc are all not all are even, right? Not all are even. Assume not all are even. Assume that not all are even. Why? Because I can always take the power of 2 out, the highest power of 2. So not all are even means something must be odd, right? I can suppose, for example, suppose a was 2 to the power lambda times p1, b was 2 to the power mu times p2, and c was 2 to the power nu times p3. One of them must be a smaller, right? So I can take that out and I can say that yes, these all are true. So I will say not all even. Now see, this this a divides no, but first see 2a will become even first of all. Check first, because this is all even. 2 4 6 here, so this one implies it's an Olympiad problem, so you have to write the reasoning also. Although obviously many people will be willing to tell that yes, ABC are all 0, because how you cannot make these kind of things, right? One means if you have got 1 and cube root of 2 and cube root of 4, you probably cannot make 0 using this linear combination, right? Integers. That's what many people will say. Okay, and in fact there can be a proof by this also. Chiranjit, you can't do by assuming ABC are prime. So if you assume ABC are prime, then it leaves many other cases also, right? So it is not the case is not exhausted, right? Because you are saying that ABC are all prime, then people may say that okay, what happens in other cases? Okay, so you can't do like that. Is that clear? You can't do like that. Is there some lag? People are not responding, so maybe that there is some lag, there is some technical glitch, but that will be all right. Yup. Okay, so we can assume this one, and then not all. So now A is even. One implies A is even. A is even. So you take A is 2A1. If you take A is 2A1, you will get 8A1 cubed plus 2B cubed plus 4C cubed minus 6ABC0. Take 2 out, so you will get 4A1 cubed plus B cubed plus 2C cubed minus 3ABC is 0. This one. 3ABC is 0, and already see now this is A is 2A1, so I can write here actually A is 2A1. I can write A is 2A1, so A is 2A1. So actually see A is even now, 2A1. Okay, so this gives you again that B is even now, right? Because everything else is divisible by 2. See, B cube plus 4, each term is divisible by 2. Right side of force is even. So anyway, you will get that 2 divides B. So 2 divides B. So A divides B and 2 divides B. 2 divides A and 2 divides B. So if you write that 2 divides B, you will get that C also is even. So I mean that you will get ABC all even. So what you will get here, it's very tricky problem. So what you will get actually, is that ABC, what we got in fact, that ABC are all even. ABC are all even. But that's contradiction. That's contradiction, because we assume that not all are even, right? That's contradiction, because we assumed not all are even. And why did you assume that not all are even? And was that assumption justified? Yes, because if something were even, then even if they were even, this ABC, I could always take out the highest power of the factor of A, B and C, and then among these whichever is least I can take them out. And so it amounts to saying that assume that not all are even. At least one must be odd. But then we got contradiction. We got that ABC are all even. And this contradiction proves that ABC has to be 0 only. Because you will keep going. It's like Fermat descent. Like you're getting descent theorem. And you are getting that. So can somebody quickly say that right now there is lag or no lag? Can just let's check that you answered quickly or what? Yes. Okay, good to know. Some people are saying no lag, but then I wanted someone else to answer, some other people also to answer. Okay, let's go to the next one. The next question is like this. This is one of the things that is easy thing, but then still we get it. So this happens like this. Prove that the number is an even number. So let's call it x. And mind you that what I will do is this way, that whenever you have got x equal to alpha plus beta, one way is that I can write x cubed is alpha cubed plus beta cubed plus 3 times alpha plus beta And again I can write alpha plus beta is x, so I get alpha cubed plus beta cubed plus 3 alpha beta x. I can get like that. But for a change, what I'll do, and to get it faster, I'll directly write this. So what I will do is that in fact I'll write alpha plus beta and plus minus x is 0. So looking at this relation as sum of three numbers, and so sum of their cubes, must equals their product, so negative of 3 alpha beta x. This is faster, way faster. See, you directly got this one. No, you don't have to do this one. So please make a note of it. And then do try. This will be really saving time for you in IIT, crucial, or any IOQM exam, other thing where objective exam is there. Subjective anyway, you have got lot of time always, but in contest exam, in AME, AMC, or other thing, it will really save you time. You can directly come here. It's the same way to look at it. Means sum of, I repeat, if sum of three numbers is 0, then sum of their cubes is 3 times the product of those numbers, right? Okay, so this is this. So alpha cubed plus beta cubed minus x cubed is negative of 3 alpha beta x. This I will always use. So using this one, I can write this way, that this is x cubed. So this is cube root of 45 plus 20. This is 29 root 2. So this is a typo. 29 root 2 plus cube root of, this is also 45. So cube root of 45 minus 29 root 2 and minus x equals 0. So I can write sum of their cubes, so 45 plus 29 root 2 plus 45 minus 29 root 2 minus x cubed is 3 times their product. So cube root of 45 minus 29 root 2 and 45, I wrote plus first, so 25 minus 29 root 2 and times minus x. Now note that this becomes 90. So you get 90 minus x cubed is 3 times, and this is 45 square. So 45 square is 2025 and 29 square, so this is 2025. 29 square is 841 and times 2, so that gives you that 1682, and so you are getting 1682. Just check it. 841 and this will getting 2025, right? And so you are getting here 343, correct? You are getting here, you can check that later, 343. So you will get 3 times 7 times negative x. So you'll get x cubed minus 21x minus 90 equals 0. So you'll get x cubed minus 21x minus 90 is 0. And by rational root theorem, we can see the one root. So one root, can somebody guess one root of it by rational root theorem? By divisor of constant term, that which divisor you pick and say that yes, that's a root. Because if I get one root, it is enough for me. I can get all, thanks to rational root theorem. Yes, so somebody can write in the chat box that what he is getting, which root he will get. X cubed minus 21x minus 90 is 0. Using rational root theorem, I'll get some root. One root, I need to get one root. So if someone can tell in comment box, then of course it would be great. It would tell that yes, you are right and you really are interested. I'll just give you some time, maybe half a minute. Okay, let me tell you that 6 is a root. If you check this one, this is px, if you call it px and check for p6 is 216 minus 126 minus 90, that gives you 0. So 6 is a root. So if 6 is a root, then I can write, let me change the page, and x cubed minus, so x cubed minus 21x minus 90. This I can write as x minus 6, and because we have got this one, so x squared, and see, I just factorizing, this is 6, this is negative 6 squared, and you want 0, so x squared plus 6x and minus 15, plus 15 is 0, and this, for this one, discriminant is b square minus 4ac, this is less than 0, the whole is less than 0, and so no root, and so no root, right, no real root I mean, and so x equal to 6 is the only real root, and when we got that the value of this expression, which looks sum of two irrationals, cube root of 45 plus 29 root 2 and cube root of 45 minus 29 root 2, those irrationals, and they give you some rational number 6, correct? So this might be that the part that was rational, that the part that was not rational, that is getting cancelled, right? So we got this one 6. So that's a good method. Okay, let's go to the next one. This came in Delhi RMO long back, once upon a time. Why I'm using this phrase, because it was actually one of the beginning time, and so it was supposedly simple. Now of course you won't get such a simple question, but still you can get it in PRMO in some factorization or some other things you can get. That is all, that can always happen. So now this tells you, see, people who attempt this problem, why this is difficult or why this was asked, that those who attempt it, first of all, they argue like this. They write x cube equal to 8, and they write t squared plus 5t plus 8, and they try to find in quadratic roots, but sadly roots are not there, real roots are not there, right? Because if you take this one, if you take this as pt, then zeros of this, that pt is 0, that will be negative b plus minus root b squared minus 4ac over 2. So you get complex number, and so people see that no, this does not factorize. No, so imagine this had been t squared plus 5t and plus 6. They would not have any problem, because they will write t plus 2 and t plus, they would be happy, and they'll write x cube plus 2 and x cube plus 3, and they would be done, right? But here this is they think that it may not be factorized. Probably that was the part of question, that was why question was asked. Okay, so now let me see how we can ask this question and how we can do it. So I can do like this, that it seems that maybe that it was modeled on a cubed plus b cubed plus c minus 3abc. Let's see that if I can discover that we can discover that for ourselves, that is it something like a cubed b cubed c minus 3abc. So let me check like this, that if I write x square cubed, that's all right, and plus 2 cubed is all right, 2 cubed I see, and then I can write here that a cube b cube plus c cubed. So let me write here some lambda x cubed, because I do not know 5x cubed, lambda x cubed, and minus 3 times x square times 2 times lambda x. So what happened, that this x cubed term has got mixed up, right? Because it is made up of some other terms, 2 terms, right? That is why probably we are not able to differentiate that. Yeah, it is not working because it need not work also, elite. It need not work also, right? Just because it does not have a root, just because it does not have real root, does not mean that this cannot be factorized. This of course can be factorized. This of course can be factorized. It has no reason for this. You will understand soon that what is happening. I would say like this, that you are getting t squared is this much, so you will get x cube you are getting alpha, and x cube you are getting say alpha plus I beta, and you are getting alpha minus I beta, because this is real, right? You will get x cube like this. So it may happen that x has a root p, q and r, complex number, and this x will get p bar, q bar, r bar conjugate. So in fact you can again multiply them, right? and so it may happen that yes, the root may be there. So that's a good question. That so it does not mean that it will not be real. It may factorize. So now see, this is lambda x cube. I can compare with 5x cube to uncover that what lambda must have been. So this is lambda cubed and minus this is 6 lambda equals 5. So I get my inspection that lambda is -1. -1 fits the bill. And so we have discovered a method that what it might have been. It will help you, this method, if the number was not so discernible that -1. Lambda might have been 3 or 4 or -4 or some other number. But this method will take it out. It will bring it. So like that we get this, by the way, 2. This is, by the way, 2 3x squared times 2 times lambda x. Okay, now lambda is -1, so we can rewrite things again. So let me write here only, and then I can move to the next page. So this is x squared cubed plus this is minus x cubed plus 2 cubed. A cube equals c cubed minus 3 times x squared minus x and 2. Just check that everything is all right, because you get plus 5x cubed. And so now the factorization is x squared minus x plus 2, a plus b plus c, and a squared plus b squared plus c squared minus ab, and so minus x cubed, so plus x cubed minus ab minus bc plus 2x and minus 2x squared. So you get this as factorization. We can also further say that I told that it's not working. Elite, I think I answered the question, but I will again answer it. So this one, okay, let me go to the next page. So this we can factor. If we can also show later on that whether this factorizes or not, if the question is asked, right? That is kind of irreducibility test. We can determine that. Okay, I will tell you next one, that this question that you are asking. So x6 plus 5x cubed plus 8, why this is not working? That if you write x cube as t, this is t squared plus 5t plus 8. So this t has got negative here, discriminant, right? b squared minus 4ac over 2. So negative 5 plus minus and root of 7 times I over 2. Now what I'm saying is this, that this is of course not real, right? But does not mean that other is not real, right? Because what will happen, that see, this t, assuming t only, so this t is x cube now. Assume one of them as alpha plus I beta, right? Alpha beta real. The other root will be x cube is alpha minus I beta. They are conjugate. If you get x, you will get 3 cube roots of this, right? You will get 3 cube roots. Name the cube roots as I said you p, q, r. They are the cube roots. Name it p, q, and r. Cube root of x. From this you will get p, q, r. You understand? From this x you will get p bar, q bar, and r bar. So if I write this as x cubed minus alpha plus I beta, I can write, not a problem. And x cubed minus alpha minus I beta, x cubed minus alpha minus I beta. If I write like this one, then I can write this as x minus p, x minus q, x minus r. 3 roots will be there, r. And here you will have x minus p bar, x minus q bar, x minus r bar. You understand? They'll all conjugate. They'll have those kind of thing. Okay, and so conjugate means that of course, like we say not conjugate may not be the proper thing, but then it may happen that these two things will be again becoming real, right? Here it may not break till here, but of course one will be there, right? Cube root of this. So cube root of alpha plus I beta is also of the form, no, something. So you will get this number, right? So omega will be there, right? So let's say this way, that x minus p omega. If one root, or say like this way, if one root is p, x cube equal to alpha plus I beta. So one of the cube root, so one cube root, so say that this is p cubed, means p is 1 cube root of alpha plus 1 cube. So answer will be x minus p omega x minus p omega square, right? And other will be x minus, this is p bar, x minus p bar omega, x minus p bar omega square, right? This kind of thing. So you can have again this thing, that this x minus p and x minus p bar, they will of course give you real, x square minus p plus p bar x plus pp bar, this will be real. But the other thing, if when you combine x minus p omega and x minus p bar omega, they are not conjugate, right? But then still you can have, if omega square also is there, right? So you can combine this one first, p omega and p omega square, and this one. So total you can combine. So it still be real again. You can show that result is again real by combining these two. If you ask, like these two will be giving you what? X square minus p times omega plus omega square and plus p times omega cubed. So you'll get x square and plus px and plus p. This you will get from here, x square plus px plus p. And so from here also you'll get p prime x plus p prime, and then we can have the factorization, right? So it's a good question. That's why you was asked. Let me go to the next one. There is one inequality based on it, inequality. And as you know, inequality is normally tougher part of Olympiad. Normally tougher part inequality. This is also lovely. So this was asked in one national Olympiad. Some other country, Romanian probably. Okay. So this is given to be distinct positive integers. And then you have to prove something, that this is proof that this one. So let me use this one first. So first of all, positive integers, and this is given. So I can write a cubed plus b cubed plus c cubed minus 3abc. I can write as a plus b plus c times a squared, b squared, c squared minus ab minus bc minus ca. Now they are all distinct positive integers. So we can assume something, right? We can assume that so this, let us talk about this thing, that how big or something this is. So assume a greater than b greater than c, distinct, so without loss of generality. Assume this without loss of generality. And so we know that a minus b greater than equal to 1, b minus c greater than equal to 1, and but a minus c greater than equal to 2. ABC. Minimum is this. So I can, this was asked in IT, this idea. A squared, b squared, c squared minus ab minus bc minus ca is half times. So it is half times a minus b squared plus b minus c squared plus c minus a squared greater than equal to half times. And you see, this is 1 squared, 1 squared and 2 squares, that's 3. So we get that this is greater than equal to 3. This is greater than equal to 3. So 3 times a plus b plus c. So let me write, this is a tricky one. So let me add the page. So I'm getting a cubed plus b cubed plus c cubed minus 3abc. This is greater than equal to 3 times a plus b plus c. Let's keep it. This we get. Now I want to get some bound on a plus b plus c. So suppose I write like this way, that, and you see, given ab plus b plus ca, 3a square minus 1. So let's use that. Given ab plus bc plus ca greater than equal to 3k square minus 1. I want to find bound on a plus b plus c. Means I want to find, this is my goal. This is my goal now, new objective. This is my goal. So how do I find that? So one approach is this, which does not yield that answer, is this, that suppose I write that a plus b plus c square greater than equal to 3 times ab plus bc plus c, right? If I write like this, this is true, because this is a restatement of, this is just equivalent to a square plus b square plus c square greater than equal to ab plus bc plus ca, which is true. Okay, but then see, this does not give you result, because you get a plus b plus c squared greater than equal to 3 times, this bound is short, 3k square minus 1, right? This is 3k square minus 1, 3k square minus 1. And so this does not give you the correct bound, correct result. What has gone wrong? Because see, they're distinct positive integers, so maybe we are selling it too short. No, we are not making full advantage of real numbers. So this is not a good bound. This will not give you the answer. It will fall short of answer. No, minimum is sort of that. So what I do here, that I do differently. So this does not work. This does not work because ABC are given to be integers, and so our bound is not really good bound. For real numbers, it might have been a good bound. So now we do like this, that I directly expand. So to get a plus b plus c, I write this as a squared b squared c squared plus 2 times ab plus bc plus ca. This I can write. Okay, so I write this as a squared b squared c squared. Remember, minus ab minus bc minus ca, because this we know. For integers, this I know is greater than or equal to 3. So let me write that. And plus 3 times AB plus BC plus CA. Now all is good because I get greater than or equal to, this is 3, and plus this also I know, that is 3 times, and you see this is 3k square minus 1. So 3k square minus 1. Now bound is improved. This 3 cancels. So this is equal to 9k square. Bound is improved. Earlier it was 9k square minus 3. So we don't know. Right? So 9k squared. Now we are good because if there are positive integers, I get this is greater than or equal to 3k. 3k. Then alright, then my job is done because I got this one 3k. So it means combining 1 and 2, I can write that a cubed plus b cubed plus c cubed minus 3abc greater than or equal to 9k. I can divide by 3 just to give the answer in the suggested form. A cubed plus b cubed plus c cubed by 3 minus abc greater than or equal to 3k, and that's the answer, this one. So this is a good proof based on this one. The thing to remember is that here it does not work because apparently you have a lower bound that does not work. So you want to improve the bound, so you go this will improve the bound. I hope that is clear. Any doubt till this point? Anything you want to ask or you'd like me to go over? Any problem? Okay. Now problems are difficulty level is increasing now. Now here again another one I'll write here. It looks sum of 3 cubes, right? Because 2. So x cubed y cubed g cubed minus 3xyg. That of course is x plus y plus g. And I will write like form half of x minus y square y minus g square plus g minus x squared. Especially interesting is the fact that if 2 of them are equal, say you write y is z, so you'll get x cubed plus 2y cubed minus 3xy squared. This same form at least, but then it will be good. So you'll get x plus 2y, and see this is 1 is 0 because x and y, so you'll get x plus 2y x minus y whole squared. Note this lemma, this simple lemma based on this. First of all, that x plus 2y, so x cubed plus 2y cubed, it is there, x cubed plus 2y cubed minus 3xy square, then this form will lead to x plus 2y and x minus y whole square. That's good, 1 perfect square and x plus 2y. That you can get directly also by factorizing, but then this is good number, this is 1. So I use in that form this one, it will be easy. So x cubed plus I, so I'll get a squared plus b squared plus c squared cubed plus 2 times bc plus ca plus ab cubed minus 3 times a square b square c square and times bc plus ca plus ab square. That will be x plus 2y, so I add them. So x a square b square c squared and plus 2 times ab plus bc plus ca and times now x minus y whole squared, x minus y. So I'll get a squared b squared c squared minus AB minus BC minus C whole squared. See, this is very beautiful now. This becomes A plus B plus C whole squared, right? And this becomes A squared B squared C squared minus AB minus BC minus C whole squared. And so that becomes A cubed plus B cubed plus C cubed minus 3ABC whole squared. That's amazing. That tells you that everything in integer, it will be divisible. So this is your thing. Yes, is all right. You are getting this idea now. So this we proved like this, that so there are similar thing which we can prove using that one. So that is this one now. So let's go to the next one. Again, you're seeing sum of 3 cubes, right? So what we can do is that I can name it, suppose. So x is b plus c, y is c plus a, and z is a plus b. Then I intend to use in this form: x cube plus y cube plus g cube minus 3xyg. I intend to use the form half times x plus y plus g, and here x minus y squared plus y minus g squared plus g minus x squared, because this form looks good because x minus y, you see. So now half x plus y plus g, that is 2 times a plus b plus c, and difference is just b minus a minus b. So I'll get here, it is same, difference is same, a minus b squared, b minus c squared, and c minus a squared, right? This same difference. So this is a plus b plus c. So this is a plus b plus c. So I can write this is 2 times a plus b plus c, or 2 times, okay, and half times a squared b squared c. So half time I will write this only, half time. So this is half times, no need to expand this, a minus b squared, b minus c squared, c minus a squared, and so that becomes simply 2 times a cubed b cubed c cubed minus 3abc. So this identity is very rich. You can have different things, right? Homogeneous also you can say, but then more than homogeneous, this is actually coming out to be good form, 2 times this one, right? So maybe sometime you are given some good expressions in IOQM especially, or other exams, and then you are asked to find the answers. This is really interesting, one of the interesting identities. Let us go over to one more. This is b plus c minus a, c plus a minus b, a plus minus c. Then you have to prove this kind of thing, x q y q g q. Again, you notice here, you notice this thing, that x plus y plus, I will first use in the form x cube y cube g cubed minus 3xyg is x plus y plus g, and I told you that this form is not good now, no? X square y square g square minus xy minus yg, that we remember always, not good because lot of expansion. So better write it as sum of squares of difference, right? So this is x plus y plus g half, and x minus y square. This I can write, right? That sum of squares of difference. So this is good form, sum of squares of difference. Here writing, so because once you write x as b plus c minus a, y is c plus a minus b, and g is a plus b minus c. Just notice that x minus y, these all are good numbers, x minus y. So see, c cancels and you're getting negative 2 times a minus b. Similarly, y minus g, negative 2 times b minus c, and g minus x is negative 2 times c minus a. You'll get this kind of thing. So that's good enough. That's good enough. And x plus y plus z is 2abc, so I will get half times, this is half, so this is half. I'll get here, by simplifying, I'll get half times, and this is 2 times a plus b plus c. That's all right. I mean, it will be just a plus b plus c, not 2. A plus b plus c. And here, I will get this as 4 times a minus b square, b minus c square, c minus a squared. And so I got 4 times half a plus b plus c. And then we will get a minus b squared plus b minus c squared plus minus c squared. No need to expand. No need to expand. We'll get just 4 times, and this whole thing becomes the way we factorized a cubed plus b cubed plus c cubed minus 3ac. They are very powerful entities based on those kind of things. Very, very powerful. And normally Olympiad problems make use of those entities in many different ways. So I hope this thing you will use very often, and you will do it often. Let me do one more from the other thing. Like let me show you the other variety, some other variety, so that you will understand. For example, this one, you have to factor this one, this factorization. Now, how do you factor that? How do you factor that? So first of all, note that lot of 3's are there, so it may be a work for a cubed plus, maybe a work for a cubed plus b cubed plus c cubed minus 3abc. Lot many powers are there. So I rearrange them. I write like this. Let me search and see that what it gives you. So this is 3 to the power 3 to the n times 3 to the n plus 3 times plus 3 to the power 3 to the n plus 3 times 3 to the power n and minus 1 plus 3 times 3 to the power n, 3 times 3 to the power 3 to the power n. This also is 3 to the power n and minus 1, right? The problem could have been more thing if you have written like this, that 3 n. Now see, lot of 3 n's are there, right? 3 to the power 3 to the power. One other way of giving the same expression could have been 3 to the 3 to the power n is t, suppose, and I could have given you t squared n plus 4t and minus 1. This would make it even more involved. This would make it more involved. T squared plus 4t minus 1, right? Because 3 to the power 3 to the power n. So this way it is there. So what I will do is this, that I will write this as in this form. So I want to make lot of cubes. So one way to make this is that identify this as 3 to the power 2 times 3 to the power n plus 3 times 3 to the n minus 1. So you can write like this as that 9 to the power 3 to the power n plus 3 to the 3 to the power n plus 3 times 3 to the 3n minus 1. Now I can write this as 9. I want cube. Still my cube has not come, but 3 is there. So I can write 9 to the 3 to the n minus 1 whole cubed plus 3 to the 3 to the n minus 1 whole cubed. So a cube plus b cube has come. Let's write minus 1 cubed, and let's see that what other things all fall in place, or there is some shorter excess. So negative 3 times 9 to the power 3 to the power n minus 1, 3 to the 3 to the power n minus 1, and times minus 1. That looks all right. Just let me say all in power of 3. So that will be, this is plus, this is all 3 times 3 to the power 2 to the 3 to the power n minus 1 and 3 to the power 3 to the n minus 1. So it becomes 3 times 3 to the power n minus 1. So 3 to the power n, and this is 3. So all right, now powers are matching. So it means we got our A, B and C. We got our A, B and C. I got my A to be 9 to the 3 to the n minus 1. I got B as 3 to the n minus 1, and I got C as -1. So now it is perfectly A cubed plus B cubed plus C cubed minus 3ABC, and this I can easily do. So let me go to the next page and do it. So, or I may add a page. So this I can easily do, and this will be now A cubed plus B cubed plus C cubed minus 3ABC. They have proved that factorize it. So of course, the moment I write A plus B plus C and A squared B squared C squared minus AB minus BC minus CA, I'm done. Sometimes some questions are asked that prove that something is composite or something. There also have to factorize. It's like algebra. You have to factorize first, and then you have to then you can conclude that yes, this factorization is not the trivial one. I mean that none of the factor can be 1, and then you are done. So Sophie German is using Sophie German also. We do many problems like that. Okay, so this is one. This came in, I think this came in Putnam long back. X cube plus y cube plus 3xy equal to 1, and you want locus of all points. So again, this is hidden is a cube, b cube, c cubed. So you got x cubed plus y cubed plus right minus 1 cubed, a cube, b cube, c cubed minus 3 times other things are placed. 3 times x times y times minus 1 is 0. So that gives you that a, factorize it, a plus b plus c and half, and write sum of squares. So this is x plus 1 whole squared plus y plus 1 whole squared plus x minus y whole squared equal to 0. This one. So I mean that this the first factor, this gives you a line x plus y minus 1 equal to 0. So locus is a line x plus y minus 1 equal to 0. So the locus consists of a line, and also this also can be 0. So the sum of squares is 0. So it means you will get x is minus 1, y minus 1 means all are equal. All are equal. So this is x equal to y equal to minus 1. No? Here x equals a equal to b equal to c. This factor gives you. So it means the locus consists of 2 points, -1, and the line x plus y minus 1 equal to 0. I mean that x plus y equal to 1. So it is this line. So any point on this line, and in particular -1 point. So -1 point. This point, single point, and so many points on this line, they are the locus of this point xy. So again, a problem based on a cubed plus b cubed plus c cubed minus 3abc. So much so for a cube, b cube, c cube, 3abc. This is an easy one. The only thing is that it will come. It has to be a like maybe little competitive. No, you have to compute, but then all the while simple. Again, I have chosen it just to give you this one. That again, whenever you have x plus y equal to something 3, bring to one side and use that sum of 3 numbers 0. Then so you can quickly do it then, because you will write here cube root of r plus 1 by cube root of r plus minus 3 is 0. If this is the case, then it means that a cubed plus b cubed plus c cubed is 3 times their product. So 3 times minus 3. So I will get r plus r, and I will bring everything this side only, nothing. So this is 9 minus 9, so plus 9. So minus 18 equals 0. So we got r plus 1 where minus 18 is 0. Now again I can play the same thing, and I can write that r plus a cube plus b cube. So I will use this again, and I will use r cubed plus 1 by r cubed and minus 18 cubed. A cube, b cube, c cube is 3 times, and then minus 18. So your answer will be r cubed plus 1 over r cubed. It's an easy one. 18 cubed minus 3 times 18. So if you do the calculation, I got this as 577. Just check that you get 5778. This is my answer. So you can check that answer later, that yes, indeed you are getting that. So this one you are getting for this one. Yes, a plus b plus c is 0, correct. So that will become little faster. Now this is a question of divisibility. So you have to prove some kind of integer thing, right? So it is saying that let xyg be integer such that this is xyg. Prove that this is divisible by 6. Means you have to prove that 6 divides. You have to prove that 6 divides. Not 6. You have to prove that x plus y plus g plus 6. This weird looking number. This divides x cubed, y cubed, and g cubed. This is to be proved that this divide this one. Okay. So what we can do is this, that I can play around the same thing again. So x cubed plus y cubed plus g cubed minus 3xyg. That will be x plus y plus g, and times half x minus y square, y minus g square, g minus x squared. This we will get. So now, can we tell something about x, y, and g? Can they all be odd? Can x, y, g be all odd? Is it possible they are all odd? Is it possible? Is it possible? Is it possible that x, y, g are all odd? Is it possible they are all odd? Use some little number theory, small divisibility test. You will find not, because if they are all odd, then right hand side is odd, but then odd minus odd, sum of odd difference odd number is even, and so left side left is even. So contradiction. So they all are not possible. At least one must be even. At least one must be even. And I can use this again without loss of generality, right? I can use without loss of generality. So I can use without loss of generality that yes, they are indeed that one of them must be even. So one of them must be even. So xyg. So I can say that 2 divides xyg. This really helps me now, because I can write here x plus y plus g and times xyg over 2. This I can write. So I can write x cube plus y cube plus g cube. X cube plus y cube plus g cube is 3 times xyg. So I will write x plus y plus g. So xyg is common here, and I write 3 plus x plus y plus g by 2. And so I can write this as x plus xyg by 2, and then x plus y plus g plus 6. And so understand, this is integer, right? This is integer. So I can write like this. So this tells me that x plus, this tells me that x plus y plus g plus 6 indeed divides x cubed plus y cubed plus g cubed. And so we can tell that this is dividing, and so we are done, that yes, this divides this. So it is still integer. This is unaltered if you substitute this for this. This we can do easily, but let me tell you one more thing. This is, so this I can do like this, that I can write a cubed plus b cubed plus c cubed. This is one expression in f a b c. So let's say f a b c is a cubed b cubed c cubed minus 3abc. So I write this as a plus b plus c, and the form is half, and a minus b squared plus b minus c squared plus c minus a squared. This I used. So half times, now replace, now I'm saying that replace a with s minus a, b with s minus b, and c with s minus c. So f of s minus a, s minus b, s minus c, that becomes half of, and see, this becomes 3s minus 2 times a plus b plus c, or 3s minus a plus b plus c rather, this one, because all are added. And here difference, so difference remains same, right? So this is still remains same, a minus b squared. This does not change, c minus a squared. And now if 3s is this much, if 3s is this much, so you are getting half times a plus b plus c, and you have got a minus b squared. You have got a minus b squared plus b minus c squared plus c minus a squared. And so you are seeing that this is still a cubed plus b cubed plus c cubed minus 3abc. So that's still in our notation f of abc, and so this remains unaltered. And then we can say that yes, it indeed works. So that was this one. So that's all for today. Let me just show you quickly before ending the session. Let me quickly show you the UCL. You know, UCL Champions League is back again. So you have got Unacademy Champions League is back once again for you. You can check the dates are 14 and 21st for group stage, and 25 questions. Time has been changed. Please make a special note of change of time, 1 to 2 p.m. And finals are on 20th November, grand finale. Question 75, and time is from, of course, 1 to 4 p.m. And lots of prizes, guys. So just check it out. Unacademy Champions League, that group stage, you see 1 to 10 rank, 20,000, and scholarship is 100%. Even if you go in 50 to 200, still you get 15%. You can scan keyword to enroll, and in finals it's much more attractive. The prize, you can see the prize money for rank 1, it's like huge. This is 1 lakh, right? And scholarship 100%, prizes and scholarships. And even if you are in the rank 51 to 200, then also you stand to get 15%. So 15% scholarships you get. I mean that even if you are doing not so well, everybody stands to win something. That's the part. Then special price week reduced by 10%. You can have this. They are slashed now. 30 months was 65,999. Now that becomes like 53,459, and you can save this much amount. You can do the maths, and you can get some kind of thing. So that was this. Subscribe now. Tell your friends also. And biggest scholarship for aspirants. That's every Sunday you have got this kind of thing. Now live test on Android and web also. Combat. And you also have, and say practice until you're perfect with Unacademy T20 Champion Test Series, 20 questions, 30 minutes. And enroll now. Use invite code. And this also is Monday to Friday at 6:30 p.m. So you have got lot of prizes everywhere. And moreover, what I feel is that it's really a good chance. You can increase your subject knowledge also, like enhance your knowledge. And of course, it's like you earn while you learn, right? That's the old age saying, and so you stand to benefit from everything. So do attend those things and go to the combat and then UCL. Especially, I would like to ask each of you to